Hello everyone and welcome to Easy Electrical. So today will be our second class on electrical machines, and we will be starting the series of the DC machines part. Okay, so what we have decided is that we will be providing you with three sets of questions on DC machines. Similarly, there will be three sets of questions on the transformers as well as induction motors, and then there will be synchronous motors, and one class will be dedicated to your single phase machines. Now you all know that by the time you must know that we are basically running our SSC online course. In that course, we basically include concept based classes, your non-technical part as well. Other than that, we also include test series, practice sets. Recording of the classes is one such facility that we are giving, and it will basically help everyone who are now doing our online classes basically, because there is internet problems are there, and some different issues basically come up, and people are not able to join the classes certain times. Other than that, lab facilities are we are trying to incorporate in this and will be updated soon. And another point is that we are trying to we basically do, exam specific notes are also provided. Exam specific notes are also provided for the easy understanding of the uh, exam, because understanding the exam is one of the key points. Now coming to today's class, that is on DC machine and electrical machines part. Now coming to the first question for today, that is the torque angle is defined as the angle between the rotor field axis and the stator field axis. The rotor field axis and the resultant field axis, stator field axis and resultant field axis, or none of this. Basically, we all know that the torque angle is your rotor field axis versus the stator field axis angle. Okay, so in details in power systems, when we deal about torque angle, we'll be dealing about the torque angle term, and certain equations are there. Okay, where you will be using this your torque angle term. Suppose there is a power expression is there, ev divided by xeq into sine delta. Okay, now this sine delta term is basically your torque angle. This is a power delivered from one level to another level, or one state to another state, for a synchronous machine. This is the power for synchronous machine. This equation I'll deal with you in power system class as well. Now coming to today's next question, that is a pole pitch is in an electrical machine is. Basically we know that there are two specific degrees, one is an electrical degree and one is a mechanical degree. Basically a pole pitch is always associated with 180 degree electrical. Okay, so it is sometimes called as the span of the two poles. Okay, span of the two poles, sometimes it is called as next term is that. Now here I have also mentioned this typical question. These two questions are basically asked in every question, every examinations. Now here you can see the relationship between theta electrical and theta mechanical. Theta electrical and theta mechanical have this relationship of theta electrical is equals to p by 2 into theta mechanical, where p is the number of poles. Okay, so this question is very much common for the SSC JE. One or the other examination you will find this question. This is a very popular question. Now coming to next question, there is a singleton coil consist of. Basically, see, singleton coil means suppose this is a singleton coil. Okay, whenever we are talking about a singleton coil, we must know there are two important factors. These two sides are sometimes are called as basically coil sides, or we call it as conductors. There are two end positions. These two end positions are called as end connections, or called as overhangs, sometimes called. Okay, now when a singleton coil is used, what we can find is that there are two conductors first of all, and there are two coil cells are also there. Okay, so the answer will be option C. But suppose I am considering a coil having say two turns for say, okay, or say three turns I'm considering like this. Okay, so this type of arrangement, what you can observe here is that here there are two coil sides. This is one coil side, this is another coil side. for a coil there is always two coil sides for a single coil. Okay, but the number of conductors here are changed. Here you can see 3 plus 3, 6 conductors are there. So you can understand from this figure, a coil having, suppose say 3 turns, will have 6 conductors and 2 coil sides. Now if we increase the number of coils, in that case the coil sides will increase, otherwise the coil side will always be 2. Now coming to next question, what is the main advantage of using a fractional pitch winding? Now to understand this, suppose this is a single turn coil I am taking, for say. Now when this coil side, suppose this is the coil, this is one coil side, this is another coil side. If these coil sides lie on the north pole and south pole, in between north and south pole, then we call it as a full pitch coil. We call it as a full pitch coil. This type of coil is called as a full pitch coil. Full pitch coil. Now suppose there is a gap. Now suppose there is a gap. That means here suppose the north pole is lying, but the south pole line is lying certain distance away from the end of the coil. The end of the coil or the coil side. In this case there is a gap. This gap is basically called as your fractional pitch. Now we all know that between the two poles the electrical degrees of separation is basically 180 degree. Okay, so here for the fractional pitch coil, this is basically your 180 degree minus alpha. Okay, so fractional pitch is done in this way. Okay, and this fractional pitching helps us in reducing the harmonics in the generated EMF. Whatever harmonics is generated, that is reduced by using a fractional pitch coil. Now coming to the next question. The armature MMF wave of a DC machine is, this is the one of the most important questions, and in every examination you will find such questions. It is basically a triangular wave. Sometimes we confuse it with the voltage induced or EMF wave, but this is actually asked as the MMF wave, the flux wave. The flux wave is basically a representation of the triangular in nature it is. Okay, now coming to next question. Now the rotational losses in the DC machine consists of, see here, a rotation occurs where? Rotation occurs basically in your rotor part. So rotor core, friction and windage losses are the main components of the rotational losses. Stator part there is no rotation. So stator core in there is no rotation. So we cannot assume that as a rotational loss. So this only option will be the correct option. Now coming to next question. Electrical machines is designed to have a maximum efficiency at, see here, uh, we design electrical machines to make it run to its optimal capacity. Optimal capacity means near the full load. Okay, so the design is kept in such a way that we obtain the maximum efficiency when it runs near the full load. Okay, near the full load is the perfect answer where the efficiency will be maximum. Now one more point we can add in the last question is that the two losses in the previous section I had already covered one question. The two losses, that is the core loss and copper loss, when becomes equal, the efficiency becomes maximum. Now coming to the next question, the ninth question. In which of the following machines open winding is used? Generally we find two types of winding. One is a open winding and one is a closed winding. Now open winding is basically used in AC machines. Basically your synchronous machines and your induction machines, we basically use the open windings, right? And wherever we find the commutator, whenever we are finding the commutator, in that case we are basically using the the closed windings. Okay, so DC machine will be the correct answer because it is saying that open winding not used, open winding not used. Okay, that's why it is called as a DC machine. DC machine or AC commutator machines that are there where commutator is involved, in those cases we are basically using the closed winding. Basically two classifications are there. One we call it as an open winding, and one we call it as a closed winding or closed winding, right? So by that understanding, open windings are basically used for AC machines without commutator, and wherever there is a commutator, basically DC in DC machines we find it commutator, we basically use the closed winding. Now coming to last question. Commutator pitch is defined as, Basically, commutator pitch is defined as there is a there is suppose two commutator segments are there, and the two commutator segments are basically joined by the uh, same ends of the sorry two ends of the same coil, in that case it is called as the commutator pitch. Suppose this is the commutator I have written down like this is the commutator segments I have just written down. Now what is commutator pitch? Suppose I am having a coil like this. Okay, I'm having a coil like this. Now, suppose one coil end is here, another coil end is, suppose I have put it somewhere like here. Okay, so the separation between the two ends of the coil, of the same coil, that is separated by how many commutator segments is called as the commutator pitch. So this is the distance between the two commutator segments to which the two ends of the same coil are connected. Okay, so it is basically the separation between the two commutator segments. Okay, now here you can see the first few points are also there. The distance between the top and the bottom coil sides of the same coil are measured from the back end. This is basically you're called as the back pitch. This is basically your back pitch. Another term is there, the distance between the two coils of the coil sides connected to the same commutator segment. If it is then connected from the same commutator segment, that is called as a front pitch. Another term that is associated with this is winding pitch. Winding pitch. Okay, so I would request all of you, those who have stayed up to this point, just go to the comment box and write a brief description about what is a winding pitch. Okay, so today that's it for today. I'm finishing my video here. If you have any doubts, you all know that we are basically having a contact number. You can directly message us at this number, or there is a email id is also there. You can directly mail us at this mail id, electricaleasy@gmail.com, and we will solve your doubts. Okay, so thank you everyone for staying up to this point.